How's it going, everyone? Welcome. We are Gonzalez here. So, in today's video, I want to take a look at the objects and mutations in Typescript. Well, this is a course taught by Matt Pocock, a software engineer who usually work Versal. Now he's currently uh, using a creator of course Typescript Essentials. When we went through the origins of Typescript, and again, I will make a quick recap of how do I get here, so I can jump straight forward to what I really care into this. So what it means is that on that course here, um, first we look at the Typescript, the original Typescript, this which was stuff where the code name of this was script char. And the reason is because all of these smart folks at Microsoft have extensive experience writing application static language. Yeah, static and compile language like C sharp, where it can give you now a hint before your code compiles or your code runs in the compilation phase. And also, some of these intelligence that are very useful. I mean, symbols, organizing or import, doing a refactoring, right? So this is this particular model where, yeah, this particular model where here we went through that and how now Typescript fits into the entire web development and why we have, right? So also look at how now that fits web development, like on the front end and on the back end, particularly why we use that on the what is the pipeline setting now Typescript here, what Typescript is so convenient doing that. What is the Typescript compiler? What is doing? What is the Typescript configuration? And how you can use, for example, static analysis compiler on CI and CD to run a static analysis. So also, how can we now make the Typescript part of the build process? And some very functional, practical libraries that we can go with. For example, uh, if we want to run Typescript nodes to do that, and this is useful for running migrate. So this is part of how you can use Typescript. Also, front-end development. You can use Vite well to leverage is some of the common things that we have developed. Front-end, backend, particularly is first we need to set up a dev server and then a test environment, right? So Vite is very integrated in these two scenarios, and when you combine that with TypeScript, it makes much more straightforward the process. So that was these two models I went through. Then look at the essentials of patience is, which is help us to annotate or let the compiler to figuring out for us by inference from their values. So JavaScript has some these primitive values. Do that annotation. There is some numbers and strings and booleans, a big int as well, undefined and null. And how you annotate, how you do that is you do that in arrays, how you define tuples, how you define map in some of the gotchas map. So you need to make that aware to Typescript compiler because it's a JavaScript built-in feature. So also how you annotate for promise, data fetching, callbacks, and handlers. And that was pretty much is that, right? Knowing the different any controversy, any type, right? And how you can also debug your JSON using now JSON parser to modify Java TypeScript how the shape. And that's at least the essential type applications. Then now we enter what is the intention behind things of TypeScript, the developers, the author of, which is there is this notion when you are developing applications that represents systems that you need to enhance their functionality or to narrow down the functionality. And in order to do that, we look at how to do that. By defining is literal types, literal values. Okay, this stands between the wideness and narrowness. So, for example, if you want to extend the type of the literal types, all right? Meaning is what are the possible values that this variable can be? Well, we have now the union type. And when it comes to understanding now what statement represent Java's TypeScript, is to also make ourselves familiar with the anatomy of statement. And this is why, at least here in the integrated development environment, we analyze that statement, anatomy of our declarations, statements. It usually is whether it is the instruction in itself, all that function, and then you assign the value a identifier variable. And this anatomy you might have is function statement, or you might have is statement, is call to action, right? Or you might have is some assignments happen. So for example, you want to store something under a identifier name, the concept. When you know this, and then you're starting to understand how you can leverage your ID, for example, help you to look at the reference from this function, how you can define this function. Also, part of the typing basic is what you type in is a function, as well as the arguments optional values that you can pass to, and the default parameter that it can have, and how, for example, in your ID, at least codes, you can use now to autocomplete feature. To first go to the definition, help you to do a refactoring of that definition name by going into the symbol, or organize the import or remove unused import. And this is pretty much what are the most common, right? So automatic code as well, but this is pretty much what are the operations with the in our ID with type. So access to a quick fix menu by some of the options that we can go in Typescript, or go to the definition, rename the definition factory, or organizing your report, or remove your. So because I make this quick segue, say, hey, this is what you can do with your object. This is what you can do when you want to enhance definitions of your system. The words describe, he wants to extend the functionality of the system by adding more of this. So union is a way of how you describe to Typescript compiler, hey, this all the possible types that this identifier or variable can. Okay? So I also look at a particular example of that. And when it comes to narrowing, right, which is, hey, if I come to now get some values out of this, I need to make sure that at least you have this set of properties, values. So with the narrowing, I look at how to do that here in Typescript. How we can leverage is for type of act as a type guard. How can also we use type guards for that? What is type guard? At the end of the day, we use type of. Some common gotcha when narrowing map, fix or throwing errors, and narrowing with the in operator to check if this property actually this object. Okay? Dealing with unknown, narrowing large conditions, and understand the notion of narrowing and wideness to say, hey, Typescript, sometimes I would like to now describe this piece of the system and extend its functionality by adding more possible values, union, or I want to cherry pick here is some of this particular value by narrowing. Right? And how now narrowing works in different, and some of this reusable type guard. And because sometimes you want to now is based on a particularly literal value, define is how this is going to look like, shape of that. This is known as discriminating, and how you can leverage that discriminating union, for example, for objects with the switch statement, with tuples, right? So all of this is just part of this notion of the intention of the Typescript author, right? And how they write this down here and say, hey, this is quite convenient as you started to develop an enhanced application. So that's quite interesting for you. Understand that unions and and with that, well, now how can we is type in object, actually go deeper into stuff, okay? So not only that, most of the time we object, look at basic typing, but also you need to extend the functionality of the in JavaScript to, for example, assign. So hey, this object, all right, I want you to add more properties to that. Property can be is values, functionality, data and functionality. So that's good. That's great to develop this intuition about this. And with that, right? So there are ways of how you can do that on JavaScript. So object data assign, hence that to extend the functionality or the data of this object, or you can use this as spread operator to do that. Why this actually is a question asked a lot in interview questions. Today, you're gonna get paid for not only maintain this kind of application, but also to extend the functionality and provide some this good guidance on how to do this. So, in the case of Typescript, in order to describe that behavior, you can also use Stringify. You want to describe the JavaScript objects, serializable value, where you transform that into like a string and then on. But in any case, this is the behavior of JavaScript, right? And I want to hit the brake here again, because what objects here in this section is describing for code is that how can we now describe the behaviors of object in JavaScript, but now in Typescript. Make it easy for annotate that behavior. So, because this is how you define, this is how you enhance or represent some of the behaviors, like extending functionality. That's prototype change and so forth. So to represent that, the TypeScript authors say we have now types and an interface. So you can define your object as a type. To extend the functionality, you use the ampersand, act like an intersection. Or you can go with interface and use the keyword extend to now point to the object that you want to extend feature. So what is the difference between types and interface? Again, another question asked a lot of questions is, well, with types, you can now describe is the typing. So with types, you can leverage the type system for defining things like dynamic generating keys. Yeah, like it's like dynamic generating keys, or aka mapping keys, or defining features in types for objects. So how you can annotate those objects. So how you can describe dynamically the keys of all the possible keys in an object, known as constraints, key constraint, restricting object key constraint, for example. How you can dynamically add keys to these objects, right? Uh, and this behavior, right, which is sometimes, most of the time, what we want to do, right? Anytime that you need to extend the functionality types, the compiler needs to recalculate that. Where unlike interface, where the idea is to replicate how the objects behave in Typescript, typing notation, the compiler now, when you use interface, it's catch that, and there are some other gotchas here. So for example, when you use now interface, and if they have the same name, it's trying to mash all of them with the latest definition, which sometimes might be useful, but it won't throw any errors like types. For example, if you have type with the same name, okay, so the compiler is going to yell at you, and it won't try to mash all of these objects. It will behave like once. So the TLDR is that with interface and types, the intention is that with interface you want to, or the Typescript wants to describe is how objects behave at runtime, okay? And try to make it efficient and effective for the compiler to keep track of all of this. Whereas type, it wants to leverage the typing annotation on this object, but some of these behaviors, like what happens when you have an object with the same name, right? Or when you want to extend the functionality, that's when now Typescript developers have some problems to conciliate that. So interface now catch your objects for that, but it tried to mash all of these interface names if they have the same name, right? With types, it won't try to smash all of them. It will create now a new type from this, and anytime that it finds some weight, anytime that you need to extend the functionality of object type, it will have to recalculate. So it won't catch. So that is two things here on the interface, right? So the interface and the type, main difference. So that's a very, very interesting thing, at least to understand. In as complicated interface, right? And then we look now at how you can work with extension types utilities. Whether it's working with partials, and specifically is what are the common things that we need to do, and what are the common solutions. So for example, sometimes we only want to make sure that this object contain is a finite set of property. So we want to have a partial, or we want to now some of these fields must be required, or we want to now omit some of those I just want to omit these properties on this object, right? So there is also something called excluding fields from a Typescript, making types property required in Typescript, and specifying a type with shared properties in Typescript. Right? How you can use, for example, is now union types. To actually say, hey, do then the functionality. So let me go with this. A quick in Typescript.
I wanted to show you an interesting little thing with omit, which is it's possible to use omit to omit properties which don't exist on the object. With pick, we saw that, okay, we've got a user type at the top. We've got ID, name, and email. And what you can do is with pick, you can't pass in stuff that doesn't exist. So we can pass in email, we can pass in name, but we can't pass in things like phone number, like this. This will error and say phone number does not satisfy the constraint key of user, and key of user means the keys of user, ID, name, and email. But if we do exactly the same with omit, you notice it just, like, it's fine, it's happy, and it returns the same type as it got in. So why does it let you do this? Well, when Typescript kind of implemented this stuff, it had a choice. It could either do a kind of strict version of omit, where it only allowed the certain keys, ID, name, and email, or it could do a loose version of omit. And it turned out that the more popular version at that time was the loose version of omit. And when Typescript adds global types into the whole, global scope, because these are available globally, don't need to import these from anywhere, what it's saying is, okay, we probably need to choose the looser option because that's going to be more compatible and error less. So you can create your own version of strict omit, and I'm going to show you how to do that in, I think, another exercise. But I think the loose version of omit is basically fine for most cases. You just need to be a little bit wary because sometimes it won't error at you in the way that you expect it to. So there you go. There's no autocomplete on omit, and you can pass in various things which will break a little bit. And I've added some links just down here to show all of the decisions that led into that within Typescript's team.
Interesting. Again, because this part of the utilities like partial it require are just the common tasks that we need as working with Typescript, right? In working with objects specifically, and that actually makes a lot of sense. Use that in some of them, not just. For example, in the case of omit versus pick. So pick actually now to complete is properties that you want to get from. And versus omit, which is more a losing implementation of, right? So here you are. All right.
In this explainer, I want to show you just a really common gotcha with both omit and pick.
Oh, sorry.
In this exercise, we have an update product function, which takes in an ID, and a product info, which omits the ID from the product. So in here, we should only have name, price, and description. But there's an interesting wrinkle here, which is with an update, sometimes we only want to update one property, maybe two properties at a time. We don't need to pass in all of the properties for that product. So down here, we've got some test cases that are saying we should be able to update just the name, just the price, description, should be able to update the name and the price if we want to, and name and description if we want to. So your job is to try to work out a way that we can describe that inside this product info type here. So we still want to omit the ID. We don't want that because we're passing in the ID as the first parameter into update product. But we also want to make it all optional. And there is a type helper that can help you do it. Good luck.
All right. So here we are with this. The name, price description, and here you are. Excluding field from a Typescript, something with product in. So to be able to update individual information. Price. To be able to update the individual. I don't understand.
In this exercise, we have an update product function, which takes in an ID, and a product info, which omits the ID from the product. So in here, we should only have name, price, and description.
Okay.
But there's interesting wrinkle here, which is with an update, sometimes we only want to
Wrinkles. What is wrinkle? Wrinkle. Some interesting wrinkle.
update one property, maybe two properties at a time. We don't need to pass in all of the properties for that product. So down here, we've got some test cases that are saying we should be able to update just the name, just the price, description, should be able to update the name and the price if we want to, and name and description if we want to. So your job is to try to work out a way that we can describe that inside this product info type here. So we still want to omit the ID. We don't want that because we're passing in the ID as the first parameter into update product. But we also want to make it all optional. And there is a type helper that can help you do it. Good luck.
Okay, if you want to make them optional in those fields, that which this, like some hooks. So if you want to make them optional, of the product, you can say is make them optional. There is a Typescript utility here that allow me to do that. Property, no. But I want to put some of them like option, right? Instead of manually having to do that, types, I want to go that types, the utility good or to make partial. So what I'm saying is if I say partial product, making the option for that. But I think that you know, that the partial omit here, make all of this exactly to make all of the keys optional, partial, right? And well, exclude or omit is this ID, but the others, ever I. So again, we are looking is at these problems that we have working with some of the convenient functions built-in method Typescript solution here.
Okay, the type helper in question is partial. Partial basically takes in, so we can say partial product equals partial, and it takes in an object, which is the object that you want to make all optional. If you hover over this, you can see that now each property, ID, name, price, description, are all string or undefined, which is super nice. So all we need to do in order to make this work for product info here is just wrap this update product or omit product ID with a partial. Now, product info is a partial of omit product ID. You notice how these angle brackets kind of stack up with each other.
Oh, interesting. I did it because it is partial of the product, the resulting type. Now, I'm gonna convert all of this product info. The problem again. I hover here and say, hey, I'm gonna make all of product info. I create this type here. So I put all of this as partial, and I exclude, so exclude or that very, very.
The opposite type helper to partial is required. So instead of making a partial of a type, this makes all of the elements required. Super useful. So coordinates here, we can see that x and y are both number or undefined, and required, after being applied to it, turns them into x number and y number, so both required. And that's really, really nice. You notice that this only works like one level deep. So if we have like a and B here, where A is required, but B inside it is not required, you'll notice that B is still not required on there. So if you want to make like a deep required, then you'll have to look at a type helper library like Typefest to help you out.
Typefest. Okay. A collection of essential type. Circle back, effortless backend with factor for convenience utility. Object, not empty object, or not array. So you started to, they are not part of the spec of Typescript. It is quite convenient to at least why they exist. Well, very. Alternative type names, specify. You know, one of our containers. Yes, dude. Some of them. So yeah, for your work, a font end. Very Typefest, Porta. Okay. Thus, Poland. They have problems They're just trying to solve them. No, period. They have problems. They're just trying to solve it. Sweden, hmm? Interesting. A backend, almost very, very interesting. Sponsor even. Oh my god. Holy those developer program. Okay. Very, very. I use daily JavaScript Postgres files in recipes are main stack and still sure that it here. How mm, that's interesting. Working on company for 40 in an AP. Can you translate that? Improve your business and web projects both. Park, major industry, and in can reach us by phone, person, and to get that or company name. 40 internet AB organization this, and they tell you we have been around since health to the rights we use to measure visitor statistic and our time. We're careful with saying all that. So okay, interesting, interesting. Get the link. Yet holy moly, Instagram. I don't think. Oh, that's it. Facebook. Oh, okay, okay, cool. Holy moly. Uh, interest again. Those people have that problem. They cannot wait for somebody to solve them. Right? Go in info. Info Geneva. Information system. They organize them. Story block. Breakpoint. Yeah, I think because there are now an agency, they have to semantic tone. Oh, that's in. Again, that's something that goes beyond the scope of today's video. Okay, you have no photography. Okay, okay. Yeah, science system for those companies. maniac, right? If I library typeface, it makes sense now. A lot of sense.
But having them just on the top level makes it a bit more predictable and is still extremely useful in a bunch of situations.
Last one.
Okay, this is an interesting exercise. We have a type of user, a type of organization, and a type of product that we've seen before. They each have three properties in common: ID, name, and image ID. And the ones that they don't have in common is user has age, organization has address, and product has price. And we have a function here called getAvatarImage. And getAvatarImage returns a URL, which basically directs to a CDN with the entity.imageID on it, and it returns an alt text saying entity name avatar. Now, your job is to work out the typing, the correct typing for this entity, which is the parameter of getAvatarImage. And you can see that we've got some test cases down here working nicely, and there's no errors down here. It's all working fine. But we want to basically make sure that this type is correct. And currently we're getting errors down here saying entity is of type unknown, so we can't access image ID on it. So your job is to work out the correct type for this entity. And it could, of course, just be like an object type with entity.imageID or entity.name, but I would like you to keep them in sync with product, user, and organization at the top. And there's a really kind of counterintuitive, beautiful way of doing it that only uses knowledge that you've learned before. There's nothing actually new in here. Good luck.
Yeah, for example, when you want to represent this identifier with all of these possible objects or typings, you can say, hey, it can be station or it can be product. And that actually, well, will work because if that entity have the age, that well, here user, that entity now have an address, means that it's an organization. So the idea of this union is that when you're going to use that, you can filter off that narrowing there to work with that specific. Right? So I think that's very, very interesting. Segmentating is possible values that this entity can be and the corner cases that you want to cover. So that'll be all for this video. Take care.